Hi, all. I welcome you all to this presentation on addressing SOTIF challenges using STPA method. Firstly, I would like to thank for giving me this opportunity to present this topic in Embedded Safety and Security Summit 2022. My name is Madhusudan Lingarajappa. I work here as a local expert for cruising functions safety concept in product line cruising for Continental. Before going to the technical content of the presentation, we will see today's agenda. Firstly, we will start with the evolution of vehicles, then the background to SOTIF, then the difference between the ISO 26262 standard to the ISO this 21448. Then we will see what are the development goals for SOTIF and what are the main challenges, how are we going to address these challenges. Then in the second part of the presentation, we will see the STPA method, system theoretic process analysis. Finally, we will conclude the presentation with few key takeaways. So to start with the evolution of vehicles, we have seen the evolution of vehicles from the early 1900 to the current generation of vehicles where we are working towards the autonomous vehicles. So most of the functions like longitudinal and lateral, which were earlier the responsibility of the driver, are now becoming the responsibility of the system here. So more and more issues are getting added into the vehicle and it is becoming very complex. So safety becomes most important here. According to SAE J316, there are different levels of automation. Level 1, here we give the assistance either longitudinal or lateral. Driver is responsible for the monitoring the environment and he is the fallback here. Coming to the level 2, here the assistance is with both longitudinal and lateral, and driver is the fallback here. In the level 3, the driver is not required to monitor the environment here, but he is the fallback. Whenever there is a request from the system to take the DDT responsibility, he should be able to take back the dynamic driving task. Coming to the level 4, here driver is not the fallback, system is the fallback. That is the difference between level 3 and level 4. And coming to the level 5, the additional aspect to the level 4 is that level 5 there is no ODD restrictions here. So these are the different levels of automation according to the J316. So in all these, while we are developing such a complex system, safety becomes most important for us. And how SOTIF plays an important role in this development, we will see in coming few slides. So, SOTIF safety of the intended functionality. This specification was first released in 2019 as a publicly available specification called ISO PAS 21448, and currently we have a draft version which is called ISO this 21448, and a final copy is expected to be released in 2022. SOTIF, according to the ISO 21448, is defined as the safety of the intended functionality, which talks about the absence of the unreasonable risk due to hazard caused by any insufficiencies of specification, including human factor limitations of the intended functionality at the vehicle level, or any performance limitations or by any reasonably forcible misuses by the persons. Finally, the security is not addressed by ISO 21448. Next, we will see what are the main differences between ISO 26262 functional safety standard to the ISO this 21448 SOTIF standard. As we all know, ISO 26262 functional safety standard addresses the hazards which are caused due to malfunctions and which are leading to the EE system failure. So ISO 26262 addresses such hazards, whereas coming to the ISO 21448, it addresses the hazards which are caused due to the triggering events due to any performance limitations of the system because of any environmental conditions or by any foreseeable misuse caused by human factors limitations, which cause system weaknesses and leading to limitations to the sensors, algorithms, and actuators, which lead to the hazards. So, SOTIF standard addresses such hazards. Next, we will see what are the different development goals for SOTIF. According to the specification, the scenarios are categorized into four different areas. Area 1 talks about known, not hazardous scenarios. Area 2 talks about known hazardous scenarios. Area 3 talks about unknown hazardous scenarios. Area 4 talks about unknown, not hazardous scenarios. For us, the developmental goal, according to the SOTIF specification, is that we have to maximize the area 1, minimize the area 2, and area 3. This is the development goal for SOTIF. Next, we will see what are the main challenges that we are facing today and event model according to the SOTIF specification. So we have seen the two hazardous areas, area 2 and area 3. So first we will take up the example with respect to the area 2. So this is known hazardous scenarios. So what is known to us? So our vehicle operating during the night. So this is known to us. There is a restriction here in with respect to perceiving the environment here. So there are certain limitations to the sensors while we are driving during the night. This is the first challenge. And the second, area 3, which talks about the unknown hazardous scenarios. So there are few examples like this. So what if our vehicle operates on a road where there is no lane marking, or there is an alien object which suddenly pops up on the road like this, or if there are any undue surfaces on the road like this in the third image. So these are few examples which are unknown to us when we are developing the functions. Lastly, human misuse scenarios. So there are certain situations where, like for example, in the SAE level 2, it is required that while we are operating the SAE level 2 system, the driver should be always monitoring the environment and he is the fallback. So if you see this example picture here, the driver is relaxing on the steering wheel, or he is using his mobile watching some videos or replying to his emails. So this is a misuse of the SAE level 2 system since he is a fallback. So how to overcome these challenges? So this is something which we will look into in the coming slides. So in the previous slide, we have seen the different areas, area 2 and area 3. Area 2 is the known hazardous scenarios and area 3 is the unknown hazardous scenarios, which may lead to an hazardous behavior of the systems, which causes any insufficiencies or some performance limitations to the sensors, which will lead to an hazard. Hazard is defined as a state or a condition together with a worst case scenario will lead to an hazard. So these hazardous events together with any misuse scenarios which are caused due to the human, which may not be controlled by persons or any external measures, would lead to an harm. So we will in the coming slides we will see how are we going to address these challenges. So how do we make a vehicle system safe? So it is very simple for us, right? Since we are more prone to accidents and risk, we can lock our vehicle in the garage and keep. So this way we are very safe. Can we do this? No, right? Since we are more prone to accidents or losses, we cannot lock our vehicle in the garage. It is most essential part of our life. Then, how do we make a vehicle system safe? We have to perform the analysis at the vehicle system level. Then we have to identify the accidents or losses. Then we have to come up with the mitigation strategies. So these measures, we have to come up with a risk prevention or reduction strategies. Next, while we perform the analysis, input for us is the specification. With this specification as an input, we have to start the analysis and identify the hazards at the vehicle system level. Then we have to assess the risk, then find the causes. What are the different causal factors or the triggering events which are leading to those hazards? Then we have to come up with the mitigation strategies. So these are the measures to prevent or reduce the risk. Lastly, we have to assure the mitigation by testing, verifying, validating, and auditing. So we safety engineers would need all your support through the project inception till we deliver the project. Next, we will see how this SOTIF analysis is performed using the STPA method. STPA stands for System Theoretic Process Analysis. STPA method has two main steps, step 1 and step 2, with a preparation step 0. So in the step 0, to start this analysis, the input for us is the specification. So with this as an input, in the step 0, we have to first start identifying the accidents. So what are these accidents? These are the losses to us or any occupants of the vehicle or any stakeholders or the vehicle in itself or any traffic participants, or it could be any financial loss also. Then we have to identify the hazards. These hazards are the state or the conditions together with a worst case will lead to an accident. So we have to identify and list down all those hazards. Later, we have to link the hazards to the losses or our accidents. Then, to all the identified hazards, we have to come up with the safety constraints, which are our safety measures. Then, lastly, we have to conclude the step 0, coming up with an control structure diagram. So, this will be an input for us in this step 1. So in the step 1, we have to identify the unsafe control actions using the guide words which are specified in the STPA handbook. Then to all the identified unsafe control actions, we have to come up with the safety constraints. Then we have to link the unsafe control actions to the hazards from our step 0. Then in the final step 2, we have to identify the causal factors, which are different triggering events which are leading to those unsafe control actions. So to all those factors, we have to come up with the safety constraints as a safety measure. So this completes the STP. In the next slide, we will see one example. Today, we will take SAE level 2 system as an example. Let us say we have a vehicle which is operating within the ODD and with this SAE level 2 system switched on. So to start with this, we will take this as an example, and to perform an analysis using an STPA method on this system, to start with the step 0. In the step 0, we have to first identify the different accidents. For our example, I have listed down two accidents here. Accident 1 reads as front collision and accident 2 reads as no assisted driving. Then we have to start identifying the hazards. So hazard 1 reads as not maintaining a safe distance to non-overridable objects. So this hazard will lead to the accident 1 front collision. Then hazard 2 reads as no automated driving upon driver's request. So this will lead to an accident, no assisted driving. Then we have to come up with the safety constraints. So safety constraint 1 reads as the eco vehicle must maintain a safe distance between non-overridable objects. Then a second constraint, if the eco vehicle violates the safe distance, then the violation must be detected and measures must be taken to prevent collision. So these are the few safety measures to mitigate the hazard. One. Then in the second constraint, SC2, you can see it is listed as no safety effect. This is because here driver is trying to switch on the SAE level 2 system. So according to SAE J316 specification, driver is responsible for monitoring the environment and he is the fallback. And in our case, he is still the responsible for dynamic driving task. He has not handed over the DDT to the system here. So hence it is considered to be no safety effect. So the last step in step 0 is to come up with the control structure diagram. So there are four different parts here: the controller, the actuators, controlled process, then the sensors. In our example, here we have two controllers. One is level 2 system, and the second controller here is the driver, because in our case he's the fallback and he's responsible to monitor the environment here. And actuators could be our steering system or braking system, and our control actions could be acceleration, deceleration, and steering. And there could be many other such control actions which are coming from the controller, SAE level 2 system, or our human driver. Then uh, they are the input for the controlled process, where it has other external inputs from other process as well. Then there is a feedback given to the controller, to the level 2 system, like the environmental perception, or it could be the vehicle speed, or steering torque feedback to the controller. These control actions which are identified in the control structure diagram becomes the input for us in the next step, step 1. In this step 1, we have to identify the unsafe control actions. So we have to use these guide words which are listed here. These are referred to by STPA handbook. Then in the example, I have taken the deceleration from the earlier control structure, control actions which were listed in the control structure diagram. So what will happen when the deceleration is not provided? So there's a loss of deceleration here. So this is an unsafe control action. Or if it is provided and which will lead to an hazard. So what could be the unsafe control action here? It could be the insufficient or excessive deceleration here. So these are the unsafe control actions. So once we identify such unsafe control action, we have to link these unsafe control actions to the hazards from the step 0. Then we have to identify the safety constraints, which are our safety measures. Next, we will see step 2, where we have to identify the causal factors or the triggering events which are leading to the unsafe control actions. So here are a few examples where the farmer is harvesting their crop on the road, and what will happen when we operate our vehicle on such road conditions. Due to low situations, our wheels might spin and it may lead to the insufficient deceleration. And in second example, where you can see a kid playing on a toy car which is operating on a wet surface or an oily surface, since he is not able to control the vehicle on such situations, it has ended up with an hazardous event here. Or third example, which could be external sun rays which is directly falling on the camera, which may lead to the limitations to the camera in perceiving the environment. So SOTIF tries to address such hazards which are caused. Next, we will conclude our presentation with few key takeaways. So ISO 21448, the final copy is expected to be released in 2022, and it was first released in as a publicly available specification called ISO Pass 21448 in 2019, and currently we have a draft version called 21448. This is an complementary specification to the ISO 26262 functional safety standard, and SOTIF tries to hazards which are caused due to the external environmental conditions or by any misuse caused by the users, drivers, uh, which may lead to the performance limitations in the sensors. And lastly, the security is not addressed by ISO 21448, and security and SOTIF are not addressed by ISO 26262. So with this, I would like to conclude my presentation here, and thank you.